Okay, so I want to take a look at the quiz 6 that you all just took and run through some of the answers real quick for all of you. So for all of these questions, you are dealing with this function f that maps the reals to the reals given by f of x is equal to x squared. So for question 1, what you had to do is you had to find f of the interval -4 to 1. So remember, what we're talking about, that this is the image of a set. So right here, this is a set. This is a set of real numbers. It's all the real numbers between -4 to 1. And we're trying to figure out, where does all of these elements get mapped to? So if we think about, you could, maybe a way to visualize this if you want to, is you think about, you're taking the thing from -4 over to 1, and you're having all of this stuff is now going to be mapped to, via the function f of x is equal to x squared, onto the real numbers. So you're basically mapping an interval to an interval. So if you think about where -4 is going to go, -4 is going to go all the way here to 16. If you think about where 1 goes, 1 is going to go to 1. So you know then that at least 1 and 16 are in these. Now you start to find other numbers that fall in between here. Say -3. -3 you see is going to be mapped over here to 9. You go over here to say -2, you see that's going to be mapped to 4. You go over here to say -1, that's going to be mapped to 1. You go over to 0, you see 0 is now going to be mapped to 0. So notice, don't be convinced that you just can simply plug in the endpoints. The endpoints help, but you also need to look at all the numbers in between. And then you can see, okay, does it ever get larger than 16? That's the question. So if you think about squaring numbers, when do you get something larger than 16? Well, that's going to be if you take something that's larger than 4 or less than -4. Anything less than 0, well, that's impossible when you square them. So what you see is that you're going to get all of these numbers between 0 to 16. So your answer here would be 0 to 16. Then if we go on to question 2, what we're asking for instead is the inverse image of this set. So the inverse image of -4 to 1. So instead, we are now, if we think about, say, this number line way to visualize this, is now you're looking at the set -4 to 1, and you're trying to figure out what was here that got mapped to these numbers. So if you think about all the numbers that get mapped to -4 from here, well, there's none, right? Because if you're thinking about, you're using this map of x squared, you know you can only start here at 0. So you try to figure out, okay, what numbers get mapped to 0? Well, you know that 0 is going to get mapped to 0. Nothing's ever going to be mapped to the negative areas, but now 0 to 1, you're thinking, okay, well, I know 1, for instance, 1 will be mapped to 1, but also you should think that -1 is also mapped to 1. And then everything in between here, you see all of this is going to be mapped somewhere in between 0 to 1. And now if you go to the right of 1, well, now you're going to be, when you square, you're going to get something bigger than 1. And if you're less than -1 over here, when you square, you're going to be something larger than 1. So you see this whole region of numbers here defines the inverse image. So your inverse image is going to be the close interval -1 to 1. Then if we move on to question 3, well, f of -1 to 3, again, you're thinking about, okay, where do all these numbers get mapped to? So remember, this is the input, so it's the range of all of these values now. And so you see that -1 is going to be mapped to 1, 0 is going to be mapped to 0, so you're going to start here at 0, and then the largest this is going to become is 9. But you're including 0, so you include 0, but we don't include 9. Because since 0 is included in the set that we're plugging in this in this original set that's being mapped, that is going to be implying that 0 is included in the range, or in this, I guess, the image here. But 3 is not included, negative 3 is not included, so we don't include 9. Moving on to question 4, now we find f inverse of f of the interval 0 to 2. So this requires us first to find what is the image of this set. So the image of this set is going to be 0 to 4. So all the numbers between 0 to 2, when you square them, become 0 to 4. And now you take the inverse image of this set. And if you go back to question 2, you could think about it again this way to figure out where are things getting mapped to. But you should see that this is now going to be the interval negative 2 to positive 2. All of these numbers, when you square them, will give you numbers between 0 to 4. Question 5, now we switch the order. Now we do f of f inverse of 0 to 2. So first off, we have to find what is the inverse image. So we're trying to find what numbers get mapped to things between 0 to 2. Well, this is going to be negative square root of 2 to the square root of 2. These are all the numbers that get mapped to that. But I'm now trying to take what is the image of this. And now if I map all of this forward using x squared, I'm going to now have 0 to 2. Then moving on to question 6, we had to find f inverse of the set containing negative 1. Now many of you were able to indicate yes, nothing gets mapped to this. But remember, this whole thing, this is a set. So it's the set that contains nothing. So it's not quite no solution. It is the set containing nothing, which is the empty set. Then question 7, many of you got this one right. Indeed, this should be a no. This does not describe a function. The reason, because you're looking at f that maps the reals to the reals, defined by f of x is equal to x times x plus 1 divided by x plus 1. And the reason why is because not every element in the domain has something in the codomain that it is mapped to. Now in particular, the element here, that's the booger, is x equals negative 1. This is the element in our domain that doesn't get mapped to anything in the codomain because, as many of you realize, you can't divide by 0. So then question 9, you need to create some type of function that maps A to B, where you need a set P is going to be a subset of A, such that P does not equal the inverse image of f of P. Now, if you look up, say at question 5 here, what we showed was that, or as if we look up at question 4 here, we have this set here, interval 0 to 2, and then we look at what is the inverse image of f. Well, you see that's negative 2 to 2. So question 4 was actually a perfect example for this, if you were to work with the sets properly. But many of you did the tried and true method of drawing a lovely picture. Make sure that you label your things. So you have A gets mapped to B. Now you need to create a set P that's over here. And so you need an element here. And then you need at least one element outside. So we can call this element, say, 1. And this element over here, we'll call this 3. And let's say we create this map. And both of these elements are going to get mapped to this element of A. So what you have here is you have the set A, you have the set P, that's a subset of A, you have your set B, but now you need to find what is f of P. Well, this is going to just be the set containing A, and then find f inverse of f of P. which is now the set containing 1, and 3, which does not equal the set containing 1, which is equal to P. So that would be what I'm looking for question 9. And then question 10, for those of you who attempted the extra credit question, you were asking, must there always be more elements in the codomain than in the domain? This was an easy no, right? You just could define this function here where you map 1 to 1. Look at this. This is a function here. There is not more elements in B than in A. So that's all you needed. All right, so hopefully that helps clarify the questions from the quiz. If you have any questions on it, please let me know, but I tried to give feedback, and if you can't see that feedback on your quiz, please let me know.